Section 5.1, page 2. So in example 2, we're asked to use 4 rectangles to estimate the area under a parabola, just a basic x squared at the origin, from x equals 0 to x equals 1. So over here is my basic parabola, and we really just want between 0 and 1, we want this tiny triangle, which is hard to see. So we've gone ahead and zoomed in over here. This is my x squared from 0 to 1. Now, because I'm asked to do 4 rectangles and we need equal width, I need to divide the region 0 to 1 into 4 equal width parts. This is going to be our delta x. So I take where do we end 1, where did we start 0, and subtract to find that we have a width of 1 unit, and we're dividing it into 4 equal parts so that we are going to step by 1/4 in each piece. So if I start at 0 and step by 1/4, I will be at my first x1. If I add another 4th to give me 2/4, or simplifies to 1/2, add a 4th, add a 4th. And you'll notice this creates 1, 2, 3, 4 equal columns between 0 and 1. So now I know where those columns are, but to find the rectangle, turns out there's lots of different ways we can look at rectangles, but we're specifically going to look at 3 different ways to choose those rectangles. The very first method is called left endpoints. What we're going to do is the left side of each column will determine the height of the rectangles. So mine didn't line up as well, but I've got those same 4 columns from above, 1, 2, 3, 4. And I'm going to start in this first column and say on the left side, I'm over here at x0. And if I plug that into my x squared, I have a height of 0, which you can see. And then I'm going to go to the left until I get to the next column marker. Well, at this next column marker, I'm now at x1, a 4th. So if I square a 4th, because that's my function, I'm going to be right here at a height of 1/16. So in this column, I'm going to come where I hit the graph and go across, and I'm going to continue this process, right? I'm at my next column. Where does the column hit the graph? Go across. So each of these, hard to see, 1, 2, 3, 4 rectangles, the left side of each rectangle is touching the graph. So now I can try to find the area from these rectangles. Well, if you remember, area is length times width, or I went ahead and wrote width times length. The width is how wide each rectangle is. We already determined they're all 1/4 unit wide. And the length, well, really that's our height. So our first rectangle was 0 units high. Our second rectangle was 1/16 units high. 1/4 and 9/16. But instead of having to deal with all this math, since each product begins with 1/4, you can basically factor that out, add the 4 heights, and take those 4 heights times 1/4, and we get 7.32. There's approximately 0.219 units of shaded area, but remember, we really wanted to shade everything, right? So the problem here is we just underestimated because we were leaving all of these sections over here unaccounted for. So instead of underestimating, let's try those right endpoints. Let's take those exact same columns that we had, the 1, 2, 3, 4 columns, but this time when we look at the graph and a column, we want the right side of each column to be touching the graph, which means we're going to have to head to the left and then kind of straight down. Hopefully you can see these rectangles a little bit more clearly. So I'm not going to start by plugging in x0, which is 0. I'm going to plug x1. When I've stepped 1/4 over into my x squared parabola, I'm at a height of 1/16. I mean, it was the same 1/16 that was my second rectangle, but now I'm using that to make my first rectangle. In the next column, when I'm at 1/2 and I square that, I am at a height right here of 1/4, and I'm going to go across and down for my second rectangle. So this continues on where I really just need my 4 heights. Instead of starting from 0 to 3/4, I start from 1/4 to 1. I get my 4 heights, I add them up, multiply by the width of each column for the area, and I get 15 over 32, which is 0.469. But as we just mentioned, I've overestimated this. So one option could maybe be to average these, or an easier way, instead of having to do it twice and average that, is to use the midpoints. We're going to use the middle of the 4 columns to determine the heights, but that means first thing we need to do is figure out the midpoints. Now you might be quick with your math and recognize that it was the 1/8, 3/8, 5/8, 7/8. Otherwise, you would have said my first column goes from 0 to 1/4, and instead of subtracting those and dividing by 2, if you add and divide by 2, it gets you into the middle. Had you subtracted and divided by 2 and gotten 1/8, you'd have to add it to 0. Not a problem here, but instead of adding 1/8 to 1/4, I'm going to go ahead and add these up, divide by 2, and I get the 3/8 already. So hopefully you can see that for each column, I've gone to the midpoint, and then I've just drawn left and right till I hit the edges of the column. Now what this ends up doing is giving me 4 more numbers I need to plug in to my x squared parabola to find their height. And again, I'm going to add those heights, multiply by the width, and I get 21/64, which is 0.328. Now the nice thing about the midpoint formula, and maybe you can't see it as well on my graph on the left, is let's take any particular rectangle. Like let's take this third rectangle. Now I did overestimate this triangle over here, but you notice I underestimated this other triangle. So most of these pieces are going to have an overestimation and an underestimation. They get pretty close to canceling each other out. I don't know how well you can see all this as I zoom out. When we underestimated, we were at 0.2 something. When we overestimated, it was almost rounded up to 0.5. When we did midpoints, we got 0.328. Later, you're going to learn an exact way to do this, and when you use that method, you'll find out the correct answer is 0.333. So the midpoint was the most accurate. But let's kind of pull all of that together in a formula. Basically, the area of a rectangle is the width, which will be consistent for all different left, right, and midpoint and other formulas we'll talk about. And then you need to multiply the height. Now, in terms of the height, it was dependent upon were we at x0, 1, 2, 3, 4, etc. And were we using a left endpoint, a right endpoint, a middle. I wouldn't think of it as an endpoint. So that's why we put this little star up here. It's the function based on whichever x sub i's we're using. And so when we talk about the area, which instead of, again, saying the sum of each width times each height, we can really think of it as the sum of the heights times the width. Seems a little overwhelming.